So the question I was asked about on a problem like this was, how do you know if you're using a positive or negative sign when you write the equation for this? And the answer is you can use either. It all depends on which portion of the graph you use to represent your phase shift. So here's kind of the steps that you would go through for this. First, you're going to find how the midline shifts. Okay? And so if we look at the midline here, the midline is the horizontal line that this graph oscillates about. So you can see that the graph goes 1, 2, 3 points above and 1, 2, 3 points below. So it goes up 3 and down 3, and so that midline is the number that it works, or that it oscillates about. So that's the x minus 2. So that means that the shift of this graph is going to be down 2 or a minus 2. Okay, so just from looking at that first part, what we can identify is when we write our graph, y equals a times the sine of, because we're asked to use sine for this, x times, or sorry, b times the quantity x minus, and here we'll look at our horizontal shift. I'll leave that blank for right now. And then our vertical shift, so minus 2 is going to go on the outside here. So just by looking at the midline, this is the piece that we can identify. Okay, so if we jump to the next step is to identify or find the amplitudes. And the amplitude is already identified here. It's the distance above and below the midline, and it should be the same number. You're going to take the absolute value of that. So the absolute value of 3 or negative 3 is going to be your amplitude. And amplitude is going to be this value a. So we can continue to build our equation. We have 3. Now, it might be a positive 3, it might be a negative 3. We'll come back and choose later when you asked, how do I know if it's positive or negative? Again, you can choose either, but I'm going to leave it 3 for right now, times the sine of b times x minus something, all minus 2. So this was the new piece that I identified in this step. Okay, so the next step then here is to find the period. And the period is the horizontal distance along the x-axis that it takes for this graph to repeat itself. Okay? And so because we're looking at a sine, the sine we're going to think repeats from midline to midline. So this is one period for a sine. If we had used cosine, the cosine's going to repeat from max to max or from min to min. And so this would be what the portion of the graph that we would use if we're finding cosine. And I'll come back and talk a little bit about that, how you can graph or find the equation of this graph as a cosine as well here in just a bit. Okay, but if we want to find the period, what we can do is for sines and cosines, the period is 2 pi. Okay, so if we think of this as being 2 pi divided by b is going to equal, and when we look on our graph, we see how long does it take along the x's or horizontally to complete one period. So since I'm using a sine, I'm going to go from midline to midline. So here I can use this midline to this midline, right? So here is one period of my graph. Okay, but I could have also used this period, this point to this point. I could have used this point here to this point. Again, midline to midline is what I would use. But for right now, what I chose was this one period right here. And what I can see is that distance goes from 1 to 7. So that's 1, 2, 3, 4, 5, 6 units. So if I take that equation, 2 pi over b is equal to 6, that's going to allow me to solve for b, this coefficient inside the phase shift. So if I solve for b right here, I'm going to multiply both sides by b to get it out of the denominator. And then I want to solve for b, so I'm going to divide both sides by 6. I get b is equal to 2 pi over 6, which I can reduce to pi over 3. So pi over 3 is my b value, which means I can now take my equation and write 3 times the sine of pi over 3 times x minus, and again, this is going to be my horizontal shift inside my function. And so once again, right now, as I look at what's newly added, it's this b value, the value inside the graph here, or inside the phase shift. And so the final step is to find the phase shift. And I'm going to completely find this phase shift here by looking where this graph shifted over. Okay, and so when I look at my graph for a cosine starts at the midline. So if I look at this midline shifted over positive 1 unit. Okay, so that number is what I'm going to plug in right here for my complete phase shift. So I get y is equal to 3 times the sine of pi over 3 times x minus 1, because that was the horizontal shift along there, minus 2. Okay, and so the last thing to determine is, am I using the positive or negative for this? Well, when I look at this, the portion of this graph that I chose to use for my sine goes from midline to minimum, to midline, to maximum, to midline. So those are my 5 critical points. So if I'm looking at that, it goes midline, minimum, midline, maximum, midline. Well, I see in my sine it should go midline, max, midline, min, midline. So what this tells me is I have my graph flipped. So I am going to need to use a negative sign if I choose to include that portion of my graph. Okay? And so what I can then find is my final answer if I just expand the phase shift in here. Okay? And so when I expand this phase shift, I get y is equal to negative 3 times the sine of pi over 3x minus pi over 3 minus 2. So this right here would be my equation. And so I can go ahead and enter that. I'll demonstrate it on here. Okay, so if I enter this as my equation, it asks me to use f of x. So if I type this in, f of x is equal to negative 3 times the sine of pi over 3x minus pi over 3. Close that off. And then the minus 2 on the outside. And then when I hit submit, notice it gives me the green check. This is the correct answer. Now, if I look at the answer key, that's not what the answer key showed, because there are different shifts that you can identify in here. And notice that this answer key had the positive 3, not the negative 3. But because I chose to use this portion of, or this period of my graph to identify all my phase shifts, my graph, or my equation is going to be slightly different. Okay, now, let's take a look at what happens if I choose to use a different one. Okay, so let's say I wanted to write my equation using a positive sign. Okay, so if that was the case, and I'm going to go ahead and I'm going to erase this portion. So I'm not going to use that portion of my graph anymore. I still have the same midline, still have the same amplitude, still have the same period. But here when I look for when I'm calculating my period, I'm not going to use this portion from midline to midline here, because that represents the negative sign. What I'm going to do is either move to the right. Now, I can move to the right, but I'm not going to see quite where this intersects. So I'm going to go ahead and move to the left. And I can view one full period from midline, maximum, midline, minimum, midline. So again, it fits the pattern of my sign. And so this now is the interval of the period that I'm going to use to calculate the rest of my equation. Okay, so again, if you recall from this step, I still have an amplitude of 3 times sine times some quantity. I still can calculate my b value. When I calculate the distance between my repeating midlines on this portion of the phase shift is, again, I see 1, 2, 3, 4, 5, 6. I do the same calculations right here, and I get b is equal to pi over 3. So that doesn't change. That's going to be the same for all of these. But what is going to change is what value goes inside here. Because now I'm using a positive sign for my graph instead of the negative one. And so when I look at what happens in this phase shift, I'm going to move my graph this direction. So this point gets shifted from what originally was at 0 to now it's at negative 2. So my shift is now negative 2. So if I plug in a negative 2 at that point, so 3 times sine of pi over 3 times x minus a negative 2 becomes x plus 2. Okay, and so this right here is my other equation, which again, if I expand, I get 3 times the sine of pi over 3x plus 2 pi over 3, all minus 2. So this is also an acceptable answer. Oops. This is equivalent to this. These two equations work for this graph. They both represent that same graph. So if I took this equation right here and I enter it instead of the negative sign, I have a positive 3 sign of pi over 3 x plus 2 pi over 3. Again, kind of move out of that and minus 2. So now I'm entering this, and when I enter and check my answer, notice it's still correct. Again, it's not what the answer shows because just the calculations that were used in this problem used a different period. It used the one from here all the way over, but it doesn't show that full period, so I used a different one. Okay? And that's how you would get your answer for that. Okay? So again, the question was, how do you know when to use positive or negative? You can use either. It's just a matter of which part of the graph are you going to use as your phase shift. Is it a part that represents a positive sign or positive cosine, or is it the portion of the graph that represents a negative? So let's take a look really quickly one more time at this graph, this same graph right here. And let's take a look at how you could also actually represent this as a cosine. Okay, so let's say I, again, kind of erase the work that I've done here. Okay, and let's say I want to express this as a cosine graph. Okay, so I'm going to go ahead and I'm going to erase this part too, because I'm going to resolve this here using cosines. Okay, now, again, if you tried cosines in this problem right here, it would probably mark it incorrect. And the reason for that is it specifically tells you that you want to write an equation for the sine. So look carefully for that. Okay, but if you want to, again, a cosine, when you're looking at it, a cosine goes from maximum to midline to minimum to midline to maximum. So what we could do for cosine is we could use this portion of the graph. Okay, so notice this represents, or this coincides with a positive cosine, right? Maximum, midline, minimum. So I know if I'm going to use that interval for my phase shift, I'm going to be dealing with a positive sign. So my midline and my amplitude stay the same. So I have y is equal to my amplitude is still 3. Again, it's a positive or a negative, but because I chose the pattern of a positive cosine, I'm going to leave it positive. Cosine of, I'm going to find my b value here, x minus my horizontal shift, and then my vertical shift is still a minus 2. So I'm just going to leave it in this form. My b value winds up being the same thing. So here with my b value, since my maximums and my minimums happen to fall at fractional parts, it's right at the 1/2, but it's not guaranteed that that's correct. I may still go in and look at from this one period where this graph repeats. I may look at it as this sine version to see how it repeats to get my period, because here when I count 1, 2, 3, 4, 5, 6, I can take 2 pi over b equals 6 and solve, and I still get that pi over 3. So that's going to be my multiplier inside my phase shift. Okay, but now when I come back here to look at how did this graph shift from the original, well, my original cosine starts up here at 0, so I shifted 1/2 units to the left. So my shift inside here is minus 1/2. And so I could have rewritten this as an equation of pi over 3 times x. Minus and minus becomes plus, so plus. And when I multiplied pi over 3 times 1/2, I get pi over 6 minus 2. So this equation right here would also be equivalent to the other equations that I have entered. Now I'm going to go ahead and try it and just see. I can't remember if I set this equation to force you to use a sign, but let's go ahead and see if I type in cosine, or 3 times the cosine of pi over 3x plus pi over 6. If I close that off, and subtract 2. I'm going to double check here, and when I hit submit, notice it here, it accepts this as the correct answer. So I didn't specify in I didn't specify in the code that you have to use sign, but it does ask for that. And it is possible that if I ask you to write it as a sign, that the code will require that. But notice here, it doesn't have to be that. Okay, so let me go through the very last form of this. Again, just to demonstrate, it can be positives or negatives, all depending on which portion of the graph you use for your phase shift. Okay, so if I get rid of what I used for this graph, and let's go through one more form of this. Again, the period is the same, so I'm not going to go back and recalculate those. I'm just going to use the b value as pi over 3. The amplitude, the vertical shifts are all the same. Okay, so let's just say, though, if I'm working through this and I want to use cosine, but I also want to use it starting at the minimum. Okay, so let's say I take this cosine right here, or this portion of the graph from the minimum, midline, maximum, midline, minimum. So that right there represents one period of the graph. Okay? And so when I look at that again, I still have this total period here of 6, and when I calculate, set this equal to 2 pi over b and solve, I get my b value to be pi over 3. So here I'm looking at the equation, again, an amplitude of 3 could be positive or negative 3, but the cosine of my b value, pi over 3, x minus, that's going to be my horizontal shift, plus my vertical shift I see was this midline of negative 2. All of that stays the same. The only thing that's going to be different here is now I'm using a negative sign because this portion of my graph is representing a negative cosine. Again, it's going to go, instead of max, midline, minimum, this is going to go minimum, midline, maximum, midline, minimum. So that's the negative cosine. So I do need to have a negative in front. And then when I look at my shift here, if it started at the 0, it got shifted 2.5 units away. So here 2.5 is 5 halves. So if I place a 5 half in there, and I write this equation, again, expand my pi over 3, I get negative 3 cosine of, distribute the pi over 3x minus 5 pi over 6 when I distribute that through, minus 6. So here would be yet another form that would be acceptable to enter your answer for this problem. And so here, if I type this in as a negative 3 cosine of pi over 3x, and this shift inside here would be negative 5 pi over 6, and the minus 2. And if I checked my answer for this, notice that's still correct. So those are 4 different versions of an answer that you can use: one positive sign, one negative sign, one positive cosine, one negative cosine. So it doesn't matter if you use a positive or a negative, it just matters based on which portion of the graph did you use to represent your phase shift. Did it represent a positive sign, a negative sign, a positive cosine, or a negative cosine?